Good morning. I am Devasena. In this lecture, we are going to discuss about timing diagram of 8085 basics and overview. This topic is present in the subject mechatronics. Timing diagram. A time diagram is a graphical representation. The 8085 instruction timing diagram represents the execution time of each instruction in graphical format. Execution time is given in T states. The 8085 microprocessor has a set of control signals and data signals that play an important role in the execution of instructions. Timing and control. During normal operation, the microprocessor sequentially fetches, decodes, and executes one instruction after another until a halt instruction is executed. The fetching, decoding, and execution of a single instruction constitutes an instruction cycle, which consists of 1 to 5 read or write operations between processor and memory or input or output devices. Each memory or I/O operation requires a particular time period called machine cycle. In other words, to move byte of data in or out of a microprocessor, a machine cycle is required. Each machine cycle consists of 3 to 6 clock periods or cycles, referred to as T states. Therefore, we can say that one instruction cycle consists of 1 to 5 machine cycles, and one machine cycle consists of 3 to 6 T states, that is 3 to 6 clock periods, as shown below. Here is a relation between instruction cycle, machine cycle, and T state. One instruction cycle comprises of 1 to 5 machine cycle, and one machine cycle comprises of 1 to 6 T states. It is represented here. There are 7 different types of machine cycles in 8085. 3 status signals, IO/memory bar, S1 and S0, identify each type as shown in table. These signals are generated at the beginning of each machine cycle and remain valid for the duration of the cycle. 8085 machine cycles are indicated here. In this opcode fetch machine cycle, the status signals S1 and S0 are 1, and the opcode is going to be fetched. Therefore, read should be active low and write bar inter is 1. In the memory read, status signal S1 should be 1. We are performing a memory operation, so IO/memory bar should be 0. For read operations, S0 should be 0 and read bar should be active low signal. Write bar should be 1, inter bar should be 1. For memory write operation, S0 signal should be 1. We are performing memory write, so IO/memory bar should be 0. S1 should be 0 because write operation is going to be performed. We are performing write operation, therefore WR should be in active low condition and read bar inter bar should be in 1. And for IO read, S1 should be 1 because the read operation is going to be performed, and IO read. Therefore, IO slash memory bar column 1. And for read operation, S0 should be 0. For read operation, read bar should be active low signal and write bar 1, enter bar 1. For write operation, IO write, IO slash memory bar should be 1, S1 should be 0 because we are going to perform write operation, and read bar should be 1 because for write operation, write bar should be 0 because it is an active low signal. Enter bar should be 1. For interrupt acknowledge, all are 1 except interrupt acknowledge because interrupt acknowledge is an active low signal. For bus idle machine cycle, IO slash memory bar S1 S0 should be 0 and the read bar, write bar, enter bar should be 1 because during that period the bus is in idle position. There is no operation performed in bus idle condition. Representation of signals. Before going to see the timing diagram, we will see the signals and these representation used in timing diagrams. Clock signal. The 8085 divides the clock frequency provided at X1 and X2 inputs by 2, which is called operating frequency. All the operations within the 8085 are synchronized with this operating frequency. Therefore, in the timing diagram, operating frequency clock is shown on the top, and then the signals are shown with reference to the operating frequency clock. Clock signal, ideal signal and practical signal representation. Ideally, the clock signal should be square wave with 0 rise time and fall time as shown in figure A. But in practice, we don't get 0 rise time and fall time. Therefore, the clock and other signals are always shown with finite rise and fall times. Figure B shows the practical way of representing clock signal. Clock signal representation is shown here. Time period T is equal to 1 by F, where F is the internal clock frequency. The clock signal comprises of rising edge or positive edge and falling edge or negative edge. One T state comprises of both a rising edge and falling edge. This is represented in this diagram. Single signal representation. Single signal is represented by a line. It may have status either logic 0 or logic 1 or tri-state. The change in the state of the signal takes finite time, and hence the state change of signal is represented with finite rise time and fall time as shown here. Group of signals representation. Group of signals is also called a bus. Example, address bus and data bus. To avoid complications in the timing diagram, these signals are grouped and shown in the form of block as shown here. In the group representation, individual state is not considered, but the group state is considered. Signal timings. In the 8085 microprocessor, signals are activated at specific instant for specific time period. Once we understand this, it is very easy to draw timing diagrams. The following section explains when the signals are activated and for what period they remain in active state. Early activation and its period. ALE, address latch enable. The signal is active high signal. It is activated in the beginning of T1 state of each machine cycle except bus idle machine cycle, and it remains active in the T1 state as shown here. A0 to A7 lower byte address. The lower byte of address is available on the multiplexed address slash data bus 80 to 87 during T1 state of each machine cycle except bus idle machines. D0 to D7 data bus. The data from memory or IO device and from microprocessor to memory or IO device is transferred during T2 and T3 states. It is important to note that in read machine cycle, data will appear on the data bus during the later part of the T2 state as shown in figure. A8 to A15 higher byte address. The higher byte of address is available on the A8 to A15 bus during T1, T2 and T3 states of each machine cycle as shown in figure. IO slash memory bar S0, S1. These signals are called status signals. They decide the type of machine cycle to be executed. They are activated at the beginning of T1 state of each machine cycle and remain active till the end of machine cycle. Read bar and write bar signals decide the direction of data transfer. Read bar signal is active, data is transmitted from memory or IO device to the microprocessor. When write bar signal is active, data is transmitted from microprocessor to memory or IO device. Both the signals are never active at a time. Thank you very much for listening this lecture. If you like this lecture means kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.